This is section 2.4, linear equations in two variables and functions. So in this section, we are going to begin with graphing linear equations in two variables. And there's several ways to graph linear equations. We're going to begin with using the x and y intercepts to do so. Before we begin, let's look at the definition of the standard form of the equation of a line. There's several different forms of the equation of the line, but this is the standard form. And in this form, one thing they did not mention here was that a had to be positive. So if you're ever asked to write the equation of a line in standard form, this a must be positive, and c, the constant, needs to be on the right-hand side. So let's go ahead and begin graphing number one. And as you can see, that linear equation is written in standard form. So let's begin with finding the x-intercept. And here, when we have an x-intercept, we let y be 0. So we have 3x equals 6 because we let y be 0. And now, if we divide both sides by 2, we get x equal to 2. The point generated is 2, 0. And we could go ahead and just plot that point right now. Let's look for the y-intercept. And with the y-intercept, we let x be 0. So 3 times 0 is 0. And we have negative 2y equals 6. Dividing both sides by negative 2, we get y equals negative 3. And the point generated is 0, negative 3. So you could think of this as when x is 0, y is negative 3, and so forth. So we have 0, negative 3. So now all we have to do is connect those lines, and we have the graph of that line. Looking at number 2, if we have the x-intercept, we're going to let y be 0, and if we have no y, we will just solve for x. There's not a y to let be equal to 0. So we'll divide both sides by 5, and we get x equal to negative 2. The point generated is negative 2, 0. That's our x-intercept. Okay, for the y-intercept, we will let x be 0, but as you can see, we would get 0 equals negative 10, so there is no y-intercept. That's a false statement. So if there's no y-intercept and it never intersects this y-axis, we can now read this a little differently. When we solved this equation, you see here, x is always negative 2. So what would that look like? Here, x is always negative 2. Okay, now looking at number 3, we have the x-intercept. We let y be 0. That is not a true statement, so there is no x-intercept. And then for the y-intercept, we have y equal to 2. Again, this can be a little bit confusing because we could have just said y is always 2 from the very beginning. Y is always 2. So if y is always 2, there's a 2, there's a 2, there's a 2 for a y value. So as you can see, we come up with this line. This needs to be moved up just a little bit. So y is always 2. And you could think of this one as x is always -2. And you can see that here. Okay, moving on, we're now going to find the slope of a line, and that will actually help us graph these equations of lines on the next page. So let's go ahead and define what the slope of a line is. So we have 2 points. We have point 1 and we have point 2. And how we will find the slope of the line is we will subtract the x values, the y values and divide that by subtracting the x values. And you can see them right here. Okay, now one thing that we need to make sure we do is be consistent. So as you can see, this is the y value of the second point, and this is the x value of the second point. So you do have to subtract those in the same order. Okay, so x2 minus x1 cannot be equal to 0 because that would make the denominator equal to 0. And that slope would be undefined if that was the case. So let's go ahead and try to find the slope of a line. I like to number these, 0.1 and 0.2. And so now let's take the y value from 0.2 and subtract the y value from 0.1. And now let's go back to the 0.2, take the x value minus a -2. And that's a -11 over 1 plus 2, and that's a -11/3. Again, 0.1 and 0.2, and we have the slope is equal to, let's go to this y value of our second point minus the y value of our first point, and then we will subtract the x values. So we have 1.3 plus 0.4 divided by 0.8 minus 1.2. And now we have 1.7 divided by -0.4. Now in this case, we can actually bring up our calculator. And if you have used your calculator's fraction capabilities, is very, very nice. So we'll start with 1.7 and divide that by the opposite of 0.4. Press enter, and now we're going to press the math button, and then we're going to press frac. And that is equal to a -17/4. So in another course, you learned how to simplify fractions and reduce fractions. So in this class, it's okay to find the reduction of your fractions using the calculator. That is not a problem, okay? You can actually use the calculator here earlier on. You'll always have your calculator with you in this class, okay? So we'll come back to that. And now we're asked to find the slope of the horizontal line, y is equal to 4. So if you think about this and you have a horizontal line, if y is always 4, so if we have slope is change in y over change in x, and if the slope is always, the slope of the horizontal line y equal to 4, if y is always 4, then we would have 0 in the numerator if we subtracted the y values. For example, you might have points on this line 1, 2, 3, but y is 4. So when we subtract these y values, we have a 0 in the numerator. So here we have the slope is equal to 0 for horizontal lines. Okay, how about this vertical line, x equal to -3? You could think of -3, -3, -3, and these are the y values. And now when you see the slope formula, if the x values are the same, this is going to be 0, subtracting 2 of these x values. So if you have a 0 in the denominator, you have an undefined value. So the slope is undefined. Okay. I kind of made a mess out of that. I could just move that over here. And as you can see, we just have that our slope is undefined. And that would be for any vertical line. And we go over that right here, linear equations and slopes of lines. As you can see, if we slant up, that's a positive slope. If we slant down, we have a negative slope. Here's our 0 slope for a horizontal line. Here's our undefined slope for a vertical line. Horizontal lines are always written as y equals a constant, and vertical lines are always equal to always written as x equals. So that's really good to remember. We have y equals 5 as your example, x equals -2 as your example. So x equals gives you a vertical line. Okay, so now let's look at another form of an equation of a line. Now we have what we call the slope-intercept. And yes, the slope is m, and that y-intercept is b. Okay, and the point generated is 0b from that intercept. So let's go ahead and write the equation in slope-intercept form this time, instead of the other form that we had here was the standard form right here. But now we're going to be in slope-intercept form. So how do we do that? Let's solve for y. That is the easiest way to remember how to write the equation of a line in slope-intercept form. So to solve this for y, we're going to add 2x to both sides. So we have 3y equals 2x minus 6. And now we will divide every term by 3 so that we can solve for y. And we have y equals 2/3 x minus 2. And as you can see here, our slope is 2/3 and our y-intercept is -2. So we will cross the y-axis at -2. That point generated is 0, -2. And now let's use the slope. So we're going to go up to, remember this, the slope will be up or down, and this will be left or right. Let's see if I can write. I can do it right here. The slope is 2/3. So we'll go up 2 and to the right 3. So let's do that. Up 2 and then to the right 3. And that puts us at this point right there. And now we can connect those points And it looks something like that. Let's solve for y again. Here we are going to add 2y to both sides, and we will have 2y plus x equals 4. We'll subtract x from both sides. 2y equals negative x plus 4. And now we'll divide every term by 2, and we have y equals negative 1/2 x plus 2. So, as you can see, our slope is negative 1/2, and our y-intercept is 2. The point generated from that intercept is 0, 2. And then we will use our slope, which will be, slope is negative 1/2. So we'll go down 1 and to the right 2. So we'll go down 1 and then to the right 2. Well, those points are pretty close, and actually we can do that. Whoops, I didn't go down on the right spot there. So we're going to go down 1 and then to the right 2, and that puts us right here. We can actually do that again. Down 1 to the right 2. So we can put another point on the graph if we wanted. And then connecting those points, that's what our line looks like. Okay, now we are going to work the other way. We are given a point on the graph and we are given a slope. So let's at least write down what we're given. We're given a point on the line and we have a slope of 5. So what are we going to do with that? We could go ahead and write y equals mx plus b, and here we will have our y value. We will have our slope, and we don't know the y-intercept. So we're going to solve for the y-intercept. Actually, I do have an x value of negative 2. So what do we have? 3 equals negative 10 plus b. And then adding 10 to both sides, we get b equal to 13. So we will use this point and plug into that equation. So now, if we have y equals mx plus b, and we have m, let's put that in the top. If we have m equal to 5 and b equal to 13, and we have y equals 5x plus 13. And that's our equation of our line. Now we're going to get to average rate of change, and it really is just the slope connecting those points that you're given. So it is the slope of the secant line if it is a smooth. As you can see, we have this smooth. So we find the slope of the line that connects those 2 points. And that is the average rate of change. So you can see the formula here, change in y over change in x between those 2 points on the graph. Now here's some new notation. F of x means y. So these are just y values. That's just y2 minus y1. Let's give it a try. Determine the average rate of change from these 2 points. So in number 11, I'm going to put a yellow dot, And we want the average rate of change between this point and this point. And on that one, we will use green. So I'm going to connect those points, and that average rate of change is really the slope of that line. So how would we do that? We would find the slope is, here's point 1, here's point 2. So 2 minus 0 over 0 minus a negative 1.5. And we have 2 divided by a positive 1.5. And putting that in our calculator, we can have 2 divided by 1.5. Whoops. And we will math fract that, and we get 4/3. So that's what the slope is. And let's make note that this is a positive slope. So the average rate of change is positive. So that is going up. As you can see, when it's positive, that line looks like that. Okay, let's go to number 12. And in number 12, I'll put this green dot. And as you can see, we want the slope of the line between these 2 points. And I'll go ahead and use a purple line and connect those. And we will write that down. So now we have point 1 and point 2. We have the slope is 1 minus 2 divided by 2.5 minus 0. And we have a negative 1 divided by 2.5. So the opposite of 1 divided by 2.5. And we will math fract that. And that is a negative 2/5. So now what do you notice here with our purple line? You notice that we have negative slope. So that makes it very nice. Okay, let's conclude this section with these few problems here. And we are actually going to be solving equations and what else? Inequalities graphically. So we really have to think through what we are looking at. The first one is an equation. You can see the equal sign. And 14 and 15, these are inequalities. Okay, so they're a little bit different. So let's work on our equation first. We want to know, where does 0.5x plus 1, and that's this line right here, where does that line equal this line, 3x minus 4? Well, let me ask you, just looking at the graph, where do you notice those points intersect at the point 2, 2? Okay, and what is the x value there? 2. So that's kind of a neat way to solve these. But we're going to go ahead and solve this by hand. The first thing we're going to do is go ahead and subtract 3x from both sides. And you can clear these decimals if you want, or you don't have to. So let's subtract 3x from both sides. And 0.5 minus 3x is going to be a negative 2.5x. And then we still have that plus 1 equals a negative 4. We're going to subtract 1, and we end up with negative 2.5x equals a negative 5. We're going to divide both sides by a negative 2.5. And as you can see here, we will have a negative divided by a negative is a positive. So we'll just go ahead and divide 5 by 2.5. And you probably already figured out that that was 2. That wasn't too bad because 2.5 goes into 5 twice. So we have x is equal to 2. And we guessed that already because here is the point where those lines are equal to each other. Okay, so graphically, you should be able to see that those two lines are equal at x equal to x equal to 2. Okay, now let's take a look at this. Where is this line below this line? So, as you can see here, on this side of the graph over here, 0.5x is higher than this line. So that's not where this is happening. But look what happens here. Over here, when you pass, let me use a different color. I'll use this light blue. This is where the lines are equal, but here is where this line is below this line. So you could say this is the bottom line, and this is the top line. And now down here, this is where we have the top and the bottom. Now, where does this occur? This happens when x is greater than 2. So we will write 2 to infinity. That is where this line is below, looking at that inequality, less than this line. Okay, now let's switch that around. As you can see, where is this blue line here? Greater than or equal. We already know it's equal at x equal to 2, but where is it greater? It's all here with all of these x values. So that is when x is less than 2. I guess I can't erase that for some reason. So this is when x is less than or equal to 2. And that's from negative infinity to 2. And we want to include 2 since we have this equals there. And that concludes this section.